Connectivity nowadays is an important thing. In a world that is developing more and more, connectivity is a powerful tool for the society. Yet, there is a huge percentage of humanity that has no connection methods. Even those who have connection methods can instantly lose them due to a natural disaster such as earthquake, tornadoes, fires, eruptions, and so on. To prevent lack of connectivity and help in those scenarios, our project team worked on a solution to help everyone during a natural disaster. Our project, called GloboNet, consists of a balloon network that is implemented around the affected area. Alongside the people that still have some kind of connectivity and our base stations, our balloon network tries to help and find those who are in the damaged area, gathering all the possible information. This way, the rescue can be quicker and more efficient. With IoT technology, open protocols and RIOT, a real-time multi-threading operating system that provides a lot of features like flexible memory management, IPv6, UDP, co-op, and so on, we can connect our devices and share all the information gathering. To make this task easier, we split our teams into some groups. The node control group, responsible for the balloon itself, the node-to-node group, responsible for the communication between balloons, the node-to-phone group, responsible for the connection between the people phones and the balloons, and the base station group, responsible for the storage of all information that balloons gathered and display info on the web server.
I've worked mainly with the sensors, made the sensor data available for other processes. So I've extracted it, I've written the loops to extract the data and to make it available via co-op calls. I've also worked on creating co-op calls to store data from other balloons and from phones, and to send this data from one balloon to another. In the end, one of my main objectives was to create a height control loop, so the balloon can control its height by itself. So you could say, okay, target this height, like 100 meters, and then the balloon would extract its own position by GPS and calculate where it is. If it is above the threshold, then it would drop down, release helium into the atmosphere, and if it was below, it would inflate itself again to reach this goal. We now have here the balloon. We are now going to send a co-op message from this computer to the board, and release gas from the balloon or from one of them to the atmosphere, and to release the to reduce the buoyancy. So you should probably hear it hissing.
The right project was to control a camera with the microcontroller. At first I started off using a code from online, and then I tried to write a driver for RIOT so other controllers can use it as well. It was very hard at first, but then I got used to it, and I learned a lot about I2C, a two-wire interface.
So I am working on the database for realizing a database on an IoT device, which is the board. We decided to go with IonDB, and it was a package that was a bit available for us, and we decided to store all our data on the SD card. So we had to get an SD card with a component to connect it to our board, and then match each pin with the correct one. That way we could define in the code which pin is connected to which part to the SD card, and we could save data and load data from the SD card.
So we're the node-to-node team, and we have these ESP32s. They have the onboard antenna used for the other group to communicate with the phone. And then we have these external 15.4 radios that we use to communicate between the nodes.
Yes, so this is the app, and after the user already connected with the AP, he can send his status, whether it's fine or need help. Then if he's fine, he can press the button. If he would like, he maybe can add a note, like if there is something around or he can help with something, just write anything and then he send it. Of course, both outputs are already there. We have his location with his status and the note he sent. And then he can see himself and the others, and maybe if someone needs help he can go and help, or maybe all of them can see each other and try to gather in one area so they can be helped faster. And yeah, if he wanted to update his status, he can pick update status. Maybe now he needs help, and then the new status will show up, and yeah.
So the base stations are devices that connect the main balloon network to the web server. They connect to every balloon that comes in range, download from and upload data to it, and send downloaded data to the server through its REST API. So for the specific hardware, we're using a Raspberry Pi 3 per base station, along with a GPS device, so we can send the locations of the base stations to the web server.
I'm currently working on the web server side, which is directly working with the base station. The base station receives new information from the balloons and updates the web server, which is constantly being asked if there are new data by the website. The website contains a console with all the written information and a map, which has various icons with the current position of the balloons and the base station and all its information.
With the goal of transferring data between devices, teams node to node, phone to node, and base station had the challenge to find a communication channel, for which they chose co-op. With the advantage of being already featured on RIOT operating system, the Constraint Application Protocol is a web transfer protocol specialized in IoT devices.
Okay.